So in this video, we're going to talk about how do we identify cis trans isomers versus something like constitutional isomers, or is it actually the same compound that we're looking at, or is it something totally different, right? And so typically in organic chemistry, you may be given some sort of differentiation on an exam, which is typical at the undergraduate level. So let's say on an exam, you're given these two compounds. And the professor asks you, okay, well, are these cis trans isomers constitutional isomers, or are they the same compound? Now, usually when I see double bonds in this sort of fashion, I'm automatically thinking about cis trans. Now, could it be constitutional isomer? Right? Sure. I mean, they both have the same molecular formula. The atom connectivity is different with respect to constitutional isomers. Here, cis trans isomer is more geometric, right? So the methyl groups or the R groups in this case may be in different positions spatially, right? So one of the things that you want to do to prove that, okay, well, to conclude that, okay, well, maybe these are cis trans isomers, is that what I usually do is draw a line, a plane of a line down the double bond, right? And so in this case, or R groups, and remember in organic chemistry, we really have CH3 as our R group. We just didn't write it, but these are CH3s. Right? These are methyl groups. Now in this case, and these are hydrogens. Right? So you could actually fill it in just to make things look a little bit more easy visually. Well, now I'm looking at the R groups. Right? In our groups in this case, usually we don't consider hydrogen on our group. In this case, methyl group, the methyl groups are our groups. Right? And you could see on this side, when you draw the double bond, when you draw a plane of symmetry down the double bond, you could see that the methyl groups are on the same side. Versus opposite, on this side, the methyl groups are on the opposite side across the double bond. And so we say that these are actually cis trans isomers. Right? Again, you could be mistaking this for constitutional because they both have the same molecular formula. But again, constitutional isomers, the atom connectivity is different, right? Geometric isomers or cis trans isomers, we are talking about specifically spatially, right? So within space. All right, how about this one? What if you're given this on an exam? And you were asked, okay, well, what is the relationship based on what we kind of wrote initially? What would be the answer? So these two compounds, how would you differentiate? Well, these are cis trans isomers. Most likely not. There's nothing geometrically and there's nothing geometric about the problem, so there's no different atom connectivity in space that we could say, okay, well, this is cis trans. Now, are these different compounds? Well, the first thing I like to do is are these the same molecular formula, right? And in fact, you would actually see that these are the same molecular formula, because in this end I have 6 carbons, right? So in this case, this would be C6H, right? Now 2, 4, 6, 8, 10, right? So I have 10 hydrogens and 1 oxygen. Here on the right hand side, I have 1, 2, 3, 4, 5, 6. I do have 6 carbons. How many hydrogens I have? Well, I have 3 as a methyl group. I have 1 here beside the OH, which is 4. And I also have another one here, which is 5, right? I do have 2 here, which is 7. I'm sorry, not 2, but 1, excuse me, right? Because they're a double bond, so that's 1 hydrogen. I do have 1 here, which is 8, right? I do have 1 here, and as a CH2, and this is a CH2, right? So how many hydrogens do we have? Well, I have 3 for the methyl group. This one right here beside the oxygen will make 4, and 5 would be the one right here. We have 6, 7, 8, and then we have 2 that makes 10, right? And then we have obviously 1 oxygen. So we have the same molecular formula. The atom connectivity is different, right? So the same molecular formula, but the atom connectivity is different. And so these are what we actually call constitutional isomers, right? Same molecular formula, the atom connectivity is quite different. How would you differentiate based on what our prowess was? What would you classify these two compounds as, right? Based on the question that I asked earlier, right? I want you to pause the video and kind of try this yourself. Right? Are these two compounds constitutional isomers? Are they cis trans isomers? Are they the same compound, or are they in fact different? Right? Now we could obviously eliminate cis trans isomers because again, it's about it's about spatial orientation with respect to our groups, right? So there's nothing in these two structures that say, okay, well, we're speaking something, we're speaking of a difference spatially, right? Now, in order for it to be constitutional, remember the molecular formula has to be the same. And immediately we could actually rule that out because look, on the left hand side, we have 1, 2, 3, 4, 4 carbons. So we have C4, right? On the right hand side, how many carbons do we have? 1, 2, 3, 4, 5. We have C5. And we don't have to actually go any further because we could definitely see at this point the molecular formulas, irrespective of whether you get the same hydrogen or nitrogen at this point, is going to be different just because of the carbon. So at this point, it cannot be any constitutional isomers. We already ruled out cis trans isomers, and so in fact, these have no relationships, and so what we call these are different compounds. How about, let's try this one. Say you're given these two compounds on an exam. How would you differentiate between the two? Well, the first thing I like to do is first thing I like to do is get my molecular formula. And in fact, you could see that these are actually the same molecular formula. Right? Now, if you want to do it yourself, count the carbons yourself, count your hydrogens, and you should get the same molecular formula. Right? So I'm just taking a shortcut. So we know that these are the same molecular formula. Now, are these cis trans isomers? Yes, we do see a double bond, and it moves. However, we're not. Again, there's no spatial orientation that's different with respect to the problem. So we know this cannot be cis trans isomers. Now, are these constitutional? So are these different compounds? Well, in order for it to be a different compound, or they're totally not related, then the molecular formula would have to be different. And I just told you, and you may have to, and you could do it yourself. I just told you that the molecular formula is actually the same. So we know that there's some sort of relationship between the two. They cannot be different compounds, right? And so in fact, these are actually constitutional isomers. How? Right? We have the same molecular formula, so the molecular formula is the same with respect to these two. However, the atom connectivity is different, right? So the double bond was right here in this formula, whereas it moved to that carbon in the first formula, right? So the arrangement different atom connectivity, right? That's what we say constitutional isomers are. So same molecular formula, but different atom connectivity.